Today we're going to build a good old-fashioned belt grinder. So it all starts by ordering the raw material, then I write my notes out and have a think about the job. I decided I should cut up most of the steel using homemade guides to keep everything nice and square. Once it was all processed, I cleaned up the marks left over from the angle grinder and then thought of some key points to cover for anyone building along. Point 1. I have the tube steel supported by 65mm alley angle when measuring. This is so we can take advantage of the flat plane in the caliper's jaw. Point 2. Use railway lines to guide your punch instead of one solid center line. Point 3. I shaped a broken tungsten drill bit to serve as my punch. Point 4. When drilling through tube steel, drill through the weld seam, not against it. Point 5. When drilling, deburr your holes as you go. Now, this one's important. Just make guide holes. Guide hole everything. Guide hole your fucking life. With that out of the way, let's get into drilling. I'm starting with a 136mm long 40x40 tracking arm. Alright, so we're going to thread the hole. So this is meant to sit like this on the machine, tracking arm. And you're going to flip him, and then you're going to tap this hole all of the way through so that the bolt threads nicely. After the tracking arm is complete, we're on to the full tilt arm. This shows up here in the design and allows the work rest to tilt 90 degrees. These next two parts are the most important parts of this machine. They are the motor feet, and they connect the motor and the chassis column, as seen here. After the feet are done, we move on to the platen arm, which is, as the name suggests, responsible for holding the platen. Much the same as the platen arm, the work rest arm connects through the full tilt arm up to the work rest. Following these two arms, we have the receivers. These hold the platen and the work rest arms in place as well. Then onto the chassis column, which serves as the bridge in between the minge brackets and the motor feet. And finally, I'm up to the last two. The tracking pillar's hole is easy, but cutting out the rectangle parts is a little tricky. But with the aim to finish, I drew some lines and forgot to fucking record the actual cutting. But I did almost record just afterwards. With that put aside for the moment, I grabbed the base column and drilled its holes. Then drew cut lines and made cuts. It wasn't a pretty process, but it worked and can be cleaned up. With the tube steel out of the way, I progressed to the 40x10 flat bar. These two parts we're drilling now have been affectionately called minge brackets, because why not? These connect the chassis column and the base column. But, moving straight along, we have the tracking mechanism, parts 1, 2, and 3, plus an alternative gas strut for the spring. I should note that the holes sized to 8.5 are actually M10 threaded. I'm not sure how that's meant to be said. But anyway, up next we have 12 spaces. 4 M10 spaces, 4 M16.5 spaces, and 4 M10 tap spaces. Nothing more to say about them really. After they are drilled, we have the platen, or the thing that holds the platen. I'm not sure. This thing, the platen face, doesn't have anything done to it until the welding stage, but you can see what will be done to it here. The last two parts to drill are the work rest and the base plate. They beg no big explanation. In fact, keep the video quick. Here's me from the past commenting on the freshly drilled parts. We have everything drilled, everything rough shaped. The only thing that's left to do is get rid of the burrs, clean these up, remove a couple of millimeter to make this square. Then we're good to go. And now we're going to take the top back to this line and clean that up so it looks nice and pretty. To explain further what I'm doing here, the top of the base column needs to have an exact amount of distance from the chassis column in order for it to tilt to a perfect 90 degrees. So, since this was a custom order for a customer that wanted to be the first to own an Occam, I can't show you how to finish putting this together today in real life. But I can show you how to on a computer. That will have to be good enough for a couple of weeks. Weld plan. Let's start with the angle iron. This serves as our platen and has two 10mm threaded spacers welded to either end. Then we weld together the 283mm chassis column and the 242mm receivers and the tracking pillar together. Right on after that, you're going to weld together the base and the base column. 122mm in from this face. Now you're going to weld the platen to the last two M10 threaded spacers. An optional weld can be done now if you don't want to worry about motor tracking. Just weld the front foot and the 16.5mm spacers to the bottom back of the chassis column like so, making sure it's flipped correctly and the correct spacers are where they need to be. Another optional weld is to permanently fix the minge brackets into place once they've been accurately spaced. Just make sure the M10 threaded minge brackets are on the back of the chassis column. Now that I've explained that, let me cover how this all bolts together. So your motor mount feet attached to the motor via 50mm M5 wing nuts, or M8 depending on the motor supplier, which is concerning, but that happens. After the motor mount feet are attached, use the M16 threaded rod to secure the motor feet to each other. If it's not already welded in place, slide three 16.5mm spacers over the longest threaded rod piece, and follow them with the welded chassis column and secure it using an M16 nut at the bottom. If the minge brackets aren't welded in place, they can be secured using a 70mm long M10 bolt. Next, we position our welded together base and base column in between the minge brackets, and then use another 70mm M10 bolt to secure it together. Next, we place a 65mm long M10 bolt through the front of the tracking pillar, and then on the other side we screw on our 40mm gas strut alternative for the spring cable. Now let's start the next section with the 260mm long platen arm. Slot your 88mm threaded rod through the hole and fasten an M16 nut on the right side and place an M16 spacer on the left side. Immediately after that, on the same side, place the welded together platen. Now lock the platen into place with a final M16 nut, and that's that part done. Now slot that into the top receiver like so. Let's jump into the tracking arm. Up front is the tracking mechanism part 3, and at the very top back is the tracking mechanism part 1. Part 3 and 1 are held in place via 10mm long M10 Allen bolts. Under part 3 there should be a M10 split lock washer sandwiched together by two 2mm thick washers. We then attach our first heim joint to part 1 using a 35mm long M10 bolt, and then slot another 40mm long bolt through the heim joint into the arse end of another heim joint, which has a 50mm long bolt sticking through it. This 50mm long bolt connects up to tracking mechanism part 2. Then finally a 50mm long bolt slots through part 2, fastening it to part 3 using an M10 nut. Oh yeah, also, in between these two parts are two 2mm thick washers. After this, the 71mm long spring is placed through the inside bottom back hole of the tracking arm. And then finally, a fully threaded 110mm long M10 bolt is screwed up under tracking mechanism 2. And that is the tracking arm assembled. Now perch it atop the tracking pillar with a 60mm bolt and nut securing it in place. There we go, looking lovely. Not far now, bear with me. We've got a work rest arm that has the 120mm long M16 threaded rod and a nut slotted through the left side and then locked into place on the right. We now slide on our full tilt arm and lock that into place as well. And finally, a 65mm long M10 threaded rod goes up through the full tilt arm, through two 10.5mm spacers, into the bottom of the work rest. With that done, we can slot that into the bottom receiver and secure both arms with M10 threaded knobs. Now, to attach the plate and face holder, first place two more 10.5mm spacers on the left side of the platen with M10 40mm long bolts extended through. On the other side of the platen, there should be three 1mm thick M10 washers for each bolt just mentioned. This is crucial for accurate spacing. With that done, go ahead and lock the platen in place with another M16 nut. Then we attach our 2-inch idler wheels using 65mm long bolts. and we attach the tracking wheel using a 70mm long M10 bolt. Next, the drive wheel with its 24mm keyway and the belt is thrown on. And finally, that is the Occam fully assembled. I hate computers, but I feel like this computer assembly was better than nothing for the short term. Now, if you want to buy this machine, or if you want to buy parts to build it, or just plain old want help making it, reach out to Friction's Knives on social media. This is a for-profit product, but I enjoy the idea of people building their own machine using the information that's found here. That's why I made it so extensive. After all, why not save yourself some money and learn some skills along the way? Alright, that is enough of this editing program. I'll catch you all in the next video where I show off my Cinder Point 2.